All right, today we're doing Unit 5, Lesson 4, Understanding Decay. So we're going to look at exponential decay. What do you notice and what do you wonder? So looking at these two tables, things that you could have noticed if they both start at 0, 2. So they both have the same y-intercept here. The table A is increasing by 3 halves, or 1.5, between each value. But table B is not increasing by the same amount. It's increasing by being multiplied by 3 halves, or 1.5, every time to get to the next value. Table A was initially greater than table B, and now if you look at the fourth value, so when x is 4, table B's value is now greater than table A. You could have wondered if there was a pattern, and so there is a pattern. Table B is being multiplied instead of being added by the same value every time. All right, Diego has $100 to spend, and he spends a quarter of it. So how much does he have left? So logically, you might find out what 1/4 of 100 is, and subtract that. And so that's a method that we can use to figure out how to find a fraction to multiply to make it faster. So in this process, we're going to start with 100, and then we're going to subtract a quarter of 100. And so that is the first step, is to find the difference of 100 and a quarter of 100. We're going to then use the distributive property. So we're going to apply the distributive property and factor out the 100. So if you look at it, you can get back. If you do 100 times 1, you get 100. And then if you get 100 times 1/4, you have negative 1/4, and then times 100. So those are still there. We're just taking out the 100. The next step is to simplify the 1 minus 1/4. So 1 minus a quarter is 3/4. If you struggle with fractions, think about your part to whole. So the whole is on your bottom. So we have 4. So think 4 minus the numerator is 1 equals 3. So 4 out of 4 minus 1 out of 4 equals 3 out of 4. So there's your shortcut to solving fractions and figuring out what you need. Then we can use the commutative property to rearrange it and put it in the right order. So if we have $100 and we spend a quarter of it, we're going to multiply by the difference of that fraction. And we're just going to multiply by 3/4. So that tells us the remaining balance that we're going to have, instead of multiplying by a quarter that's in the problem. So let's look at another example. If a person makes $1,800 per month, but a third of that is going into rent, what two numbers will we multiply to find out how much she has left after paying rent? Well, we're going to have the $1,800, but instead of the 1/3, we're going to find the difference of that. So my part to whole is 1 to 3. So I'm going to do 3 minus 1 equals 2. So that tells me that 3/3 minus 1/3 is 2/3. So I'm going to multiply by 2/3 instead of 1/3. Next, write an expression that only uses multiplication and that is equivalent to x reduced by 1/8 of x. So here we're going to do the same thing. Our part to whole is 1 to 8. So I have 8 minus 1 gives me 7. So 8/8 minus 1/8 equals 7/8. So instead of multiplying by 1/8, I'm going to multiply by 7/8 times whatever value of x we're looking for. All right, let's look at buying a new car. So if you have a car that costs $18,000 and it loses a third of its value every year, we need to look at this as it's decaying. So a buyer's worried that the car will be worth nothing after 3 years. Do you agree or disagree? So you should definitely disagree with this, because she's thinking that it's losing a third. So I have 1/3 plus 1/3 plus 1/3. So if I subtract a third every year, I'll be out of value after 3 years. But that's not how it works, because we're taking a third of the value every year of that current price. So 2/3 is always remaining after each year. Am I right? Okay, so let's write an expression to find out the value of the car for each year listed in the table. So if we have $18,000 and we're losing a third of its value, I need to figure out what to multiply by. So if I'm losing a third, I'm going to take the whole and subtract the part. and that will give me 2/3. So the number that I'm going to multiply by is 2/3. So I'm going to have 18,000 times 2/3, okay, for the first year. So every time I'm taking that 18,000 and multiplying it by 2/3. To get the second year, we're going to have 18,000 times 2/3, because that's what we had at year one. And then we're going to multiply that by 2/3 again. Okay. And then for the third year, we're going to have to multiply it by 2/3 again. So now we're getting to where it's faster to use an exponent. So instead of times 2/3 times 2/3 times 2/3, we can do 18,000 times 2/3 to the power of 3. For 6 years, we can do 18,000 times 2/3 to the power of 6. And for any number of years, we would just change that exponent to the variable t. So 18,000 times 2/3 to the power of t. So that tells us that anytime we're multiplying by 2/3, that number will go in the exponent where t is. So our equation here, we would just set it equal to v, because that is the value that we're looking for in the car. So v, the value of the car, is equal to 18,000 times 2/3 to the power of t. So if we use our equation to find v when t is 0, what does that value mean in this situation? So that would mean that we have 18,000 times 2/3 to the power of 0. And anything to the power of 0 is 1. So 1 times 18,000 is 18,000. So that gives us the initial value of the car when t is 0. Look at a different car. It's losing at a different rate, and it's represented by the equation d equals 10,000 times 4/5 to the power of t. So what do the values 10,000 and 4/5 mean in this situation? So the value 10,000 is the initial value of the car, and the 4/5 tells us that it's decreasing by a factor of 4/5 each year. So that is our growth factor, but it is now decreasing instead of increasing like in the previous lesson. All right, so look at a digital camera worth $400. It's losing a third of its value each year. How can we express the value of the camera in dollars after 1 year or 2 years or 5 years or 1,000 years? Well, if we just look at the decay rate, it's 1/3. So we can multiply the 400 by the difference of that by taking our part to whole. So whole minus the part. So 3 minus 1 is 2. So we have 2/3 left. So we would multiply by 2/3 every year. Why does it make sense for us to use multiplication instead of subtracting from the number and then multiplying? So this allows us to write a more simpler equation, and it's faster. So it's much faster to just multiply by a number than it is to find a part and then subtract it from the whole, especially if you're dealing with multiple equations and quantities in the same formula. When we use multiplication, why doesn't 1/3 show up? It's because that's what we're taking away, and we want to represent it in the formula by what's remaining. So we're looking for the part that's left every year so that we're taking out a step of the problem. And what's the value of the camera in dollars after t years? Well, we're just going to take our initial amount, 400, and multiply it by the remaining amount, which would be 2/3, and raise it to the power of t. So for these, make sure that you understand the fraction that you're putting in your equation is the part that's left. So we're looking for the fraction that's remaining, not what's being taken away.